Good morning, good afternoon and good evening प्यारे बच्चों. In this lecture we will basically be concentrating in equilibrium of concurrent forces. So to go ahead with, first, what are concurrent forces? Just see, forces which are acting at a single point. Okay, forces acting at one point. This force, and this force. These three forces, F1, F2 and F3. These three forces are acting at a point simultaneously. एक ही time. So these three forces are concurrent forces. So how will you define concurrent forces now? Concurrent forces are the forces which act at a single point. Are called as concurrent forces. It's okay. आराम से इसको pause करके definition of concurrent forces read कर लो आप. ठीक है, same thing. Whatever I said, I have written that thing only. Okay. Now, equilibrium. What is equilibrium basically? As earlier we have discussed. Now, equilibrium. Equilibrium basically is that situation associated with any body or any object, okay, when forces are acting on the body. Forces are acting on the body in such a way that their vector sum is equal to 0. Let us see. Suppose we have a single point. These forces are acting. One is F1, another one F2, another one F3 and another F4. Okay, these four forces are acting at this particular point, this point mass. Okay, this point mass is at rest or it is moving with uniform velocity. Mean F1 plus F2 plus F3 plus F4. Vector sum of all these forces is equal to 0. Okay. When vector sum of all these forces, whatever is acting on this particular body, okay, will be 0, only in that very situation we will be saying this particular body is in equilibrium. Mean, forces are acting on the body. First thing. Second thing is their vector sum is equal to 0. It's okay. So that state of the body is called as equilibrium. As I think you are having a complete information about equilibrium now. Okay? Basic definition you must have understood. Equilibrium is that state. Equilibrium is a state basically. Okay? That state of the body when the forces are acting on the body. First thing, and vector sum of all those forces is equal to 0. Okay? अब अगर इसको बिल्कुल शॉर्ट में कहूँ, okay? Total force acting, net force acting, net external force acting, net external force acting, net external force acting on the body is equal to 0. It's okay. ठीक है. Now what happens in accordance to Newton's second law of motion? Okay, or first law also you can say, when total force acting on the system is equal to 0. Okay, net force acting on the system is equal to 0. Either the system will be at rest or it will be moving with constant velocity. Newton's second law of motion says F is equal to mass into acceleration. If net force, total force acting on the body is equal to 0, then acceleration of that body will be equal to 0. Now, in which all cases we have acceleration equal to 0, first thing, either the body is at rest, in that case also the acceleration will be 0, or it is moving with uniform velocity. In that case also the acceleration of the body will be equal to 0. Mean, a body in equilibrium, either it will be at rest or it will be moving with constant velocity, mean uniform velocity. It can't accelerate, it will never be accelerating. Okay, so after knowing about concurrent forces and equilibrium, now let's go ahead with equilibrium of concurrent forces. We have two concurrent forces, okay, acting at a point or body. Okay, the body is a point mass basically. Whenever I am saying body, so take that particular body as a point mass. Okay, we have two forces. One is F1 and another is F2. They both are acting at a point. See, one is like this, F1, and another is like this. Now, if we want, now resultant force corresponding to these two forces will be equal to vector sum. This will be the resultant force, vector sum of both the forces. Using vector laws we will be adding. Now if we want this particular point to be in equilibrium in the influence of these two forces, then the resultant has to be 0. It's okay. Resultant force has to be 0. Now you just think, when the resultant force for this F1 and F2 will be equal to 0. When these both forces F1 plus F2 vectorially added giving resultant 0. When this will happen? When F1 will be equal to minus F2. It's okay. Mean both the forces has to be equal in magnitude and should be pointing opposite to each other. Mean, when we have a situation where we have two concurrent forces acting on a body, then there will be equilibrium only in that very situation when those two forces will be equal and opposite with respect to each other. It's okay. Now, we have got the situation, we already have discussed the situation when we have two concurrent forces acting on the body and how they should be, with respect to each other, how they should be aligning with respect to each other or whatever magnitude with respect to each other. Okay, they have to be in equilibrium. This is the situation describing that particular thing. Now, let's take the case or situation of three forces now. When three forces are acting on a body, something like this. This is your one force, F1. This is another. And this is another. Okay. These three concurrent forces are acting on this particular body situated at O. Okay. This is F2. This is F3. Now, when these three concurrent forces will be in equilibrium, just see, the resultant of these two forces F1 and F2, suppose these three forces are in equilibrium, okay, mean they are like this, F1 vector plus F2 vector plus F3 vector is equal to 0. Now this will happen. It means these three forces are giving us 0 resultant. Mean these three concurrent forces are in equilibrium. Now when this will happen? This will happen only in the situation when, suppose resultant of F1 and F2 we are taking. Okay, resultant of F1 and F2 will be somewhere here, like this. Okay, this is resultant of F12. F12 is resultant of F1 and F2. Okay, so resultant of these two vectors is cancelled by the third vector. Mean resultant of these two forces, that is this, is cancelled by the third force acting on the body. This. And similar thing happens with this. Resultant of these two is cancelled by this third. Resultant of these two, F2 and F3, is cancelled by the first force. This will happen only if the forces will be like that, the resultant of any two is cancelled by the third force. Only then three concurrent forces can be in equilibrium. आराम से इसको पॉज करके रीड करो, ठीक है? Resultant of F1 and F2 is cancelled by F3, and similar thing happen for resultant of F1 and F3, that is resultant of F1 and F3 cancelled by F2, resultant of F2 and F3 cancelled by F1. Only in that very scenario the three forces, they will be in equilibrium. Mean if this will happen, the resultant of F1 and F2 is cancelled by F3, then definitely the resultant of F1 and F3 will be cancelled by F2, and resultant of F2 and F3 will be cancelled by F1. Okay, and F1, F2 and F3 in तीनों का vector sum will be equal to 0. If you go to laws of vector addition, if you apply those vector laws of addition, already we have studied this particular thing. Okay, the three forces, they will be giving 0 resultant when they will be forming a closed triangle having all sides in order. You just think of the situation, something like this: F1, F2 and F3. Okay, F3. As they are forming a closed triangle, so they definitely will be having their resultant equal to 0. And the previously discussed thing, just now which I have discussed, resultant of F1 and F2 will be cancelled by F3, resultant of F3 and F1 will be cancelled by F2. This way. This definitely will be obeying that particular thing also. Okay, when three forces we have, three concurrent forces we have, and they are in equilibrium, they have a specific relation between them. Okay, and that relation is given by Lemmy theorem. These are the three forces, okay, which are represented by the sides of the triangle. Okay, F1, this is F1, this is F2, F2, F3, F3. Now, as I said, these three are forming a closed triangle and their resultant is 0. That already we have discussed now. Now see the relation between the forces. If angle between F2 and F3, this is alpha. Okay, angle between F3 and F1 is beta, and angle between F2 and F1, this is gamma. Then these three forces, they have a specific relation amongst them. Okay, and that is given by Lemmy theorem, as already I told you. Okay, the magnitude of first force divided by angle between other two forces. Angle between other two forces. Other two forces are F2 and F3. That is sine of alpha. It's clear? And this is true for all the forces. This will be equal to magnitude of second force divided by angle between other two forces, that is F1 and F3, that is beta, sine of beta. And this is equal to third force F3, sine of angle between other two is F1 and F2, gamma, sine of gamma. This will be the relation amongst these three forces which will be in equilibrium. Okay, mean concurrent forces when we will be having three concurrent forces and they will be in equilibrium. This will be the relation amongst them. Similarly, you can have for 4 will be making closed polygon having all sides in order. Okay, and as many number of forces we can talk of. If we have n number of forces, then how we will be describing about the situation for equilibrium of concurrent forces if we have n forces acting, okay, on a body. Now, first thing, they should be forming a closed polygon having all sides in order. It's okay. And the second thing is resultant of n-1 forces. ये n है ना, इसमें से कोई भी n-1 forces आप ले लेना. Okay, the resultant of n-1 forces altogether will be cancelled by the single remaining force. It's okay. If the concurrent forces will be like that, if the concurrent forces will be like this, okay, only in this particular situation, only in these particular situations, the concurrent forces will be in equilibrium. It's okay. Only in these situations जो पहले दो बताई हैं, okay, the given n forces, okay, which are acting at a single point will be in equilibrium. Okay, you can refer to one more article that we have discussed in vectors. Okay, that was conditions for zero resultant. Okay, that will also be providing you some of the exposure in relation. Hope all these things are understood. Okay, go through the content provided and go through the things given in book also. Okay, and if there is any matter of confusion, let me know about. We will be taking it again. Thank you. Have a nice day.